we should take a look at what's actually in the headers. So what we'll do is we'll take a look at what's in the transport header and in the transport header for both TCP and UDP. And what we were just looking at was the SYN/SYN/ACK ACK response. We looked at that flags field, but what other fields are in there? What else are in these headers? What is that datagram, that transport, that layer 4 header look like? So this is the TCP segment. This is what that header looks like. So if I go back and just quickly, I know this is a little redundant here, but let's put our PDU back in here with our HTTP header. It was our GET request that we've done so far. And in front of the TCP, in front of the HTTP header was my TCP header. And in front of my TCP header was my IP header. And in front of my IP header was my MAC address header with my trailer, my FCS. And again, I probably should have put IP in here just to make sure that we have that consistent. What we're looking at on this particular screen is just the TCP header. So what's in that header? What's that data? From the Wireshark, we saw that flags field that had the breakdown of the SYN/SYN/ACK ACK. Well, that's what the flags field is here. So that's one of the headers. Clearly, you also know that in the TCP header, you have to have a source port and destination port. So yes, there's the information for us. Source port, destination port, which for our pack that we've been doing, the destination port was port 80. That was my web server port. And my source port was some random generated number, 16398. Again, just pick some random number from whatever it was. Those values are the values of the port numbers. In order to guarantee reliability, I need to be able to send segments that were dropped somehow. Maybe a router dropped one of my packets, so clearly one of my segments gets dropped as well. Well, I need to know that, so the acknowledgement is not going to include that value. I will not acknowledge a packet that I didn't get. I'll acknowledge only the packets that I did get. So the originating server that's sending this to me will be able to say, hey, you know, you were missing a segment, so let me send that back along. There's a couple of different ways that can be done. We can do just send the missing segment, or we can send everything from that segment on. The way the original RFC went is if as soon as I missed an acknowledgement number, I sent everything from that point back on, which added a lot of redundancy. Again, not necessarily how we do it today, but the fallback for that. But in my header is that acknowledgement number that we have. It's the sequence number, so I can put my data back in place. It's the window size. These are all specific to the TCP segment, so sequence number, acknowledgement, window size. That's all very specific to the TCP segment, which is the TCP header piece that we have here. Remember that we have two protocols. This was my reliable protocol, so TCP was my reliable protocol. My unreliable protocol was UDP. UDP doesn't have nearly the same information in the header. It doesn't need to. It doesn't have sequence numbers, acknowledgements. It's not necessary at all. For my UDP segment header, it just has strictly that source port, destination port, and a length and a checksum. So again, what would the PDU look like for a UDP instead if I were trying to draw that PDU out for you? So I've been using a TCP, we've been doing HTTP for the most part. Well, what happens if I'm doing SNMP? So this is SNMP, Simple Network Management Protocol, SNMP. This is UDP port 161. So this is an SNMP GET request. Well, the way that my PDU structure is built, I'm going to put the same blue header on here because that's my same top header, but instead of being TCP, it's UDP instead. I'm still going to put an IP header in front. It's exactly the same. It's the same IP address pair that we did before, as well as getting a MAC address and putting my MAC address on. And of course, you can't forget the frame check sequence on the end. So that UDP header in here is now what's being described by this particular picture. So source port, destination port, a remaining length of a packet, and a checksum. That's all we have in the header. So again, in my UDP header, source port, destination port, that's the same as the TCP header. My TCP header has a source port, destination port. Length and checksum, same as my TCP header. What's different is in my TCP header is the TCP header has that sequence number, acknowledgement, and window size. That would be the difference between the TCP and the UDP headers. Again, source port, destination port in both, sequence number, acknowledgement, window size, strictly the TCP header, and this is what, again, guarantees my reliability.